Python is an object-oriented programming language, allowing you to structure your code using classes and objects for better organization and reusability. Object-oriented programming provides a clear structure to programs and makes code easier to maintain, reuse, and debug. Object-oriented programming helps keep code dry or don't repeat yourself. The dry principle is one of several clean code principles that states you should avoid writing the same code more than once. Instead, move repeated code into functions or classes and reuse it. Essentially, with object-oriented programming, you're able to build reusable applications with less code. Classes and objects are the two core concepts in object-oriented programming. A class defines what an object should look like, and an object is created based on that class. Essentially, a class is like an object constructor or a blueprint for creating objects. When you create an object from a class, it comes with everything defined in that class. Its variables, also called properties, which store the object's data, and its functions, also called methods, which define what the object can do. To create a class in Python, we use the keyword class, followed by the name of the class, for example, my class, followed by colon, and we can indent to contain something in this class. Now, this something could be a property, like a variable x, and we can set it to a value of 5. Now we can use the class that we created, my class, to create objects from it. For example, we can create an object called p1 from my class, and then we can use the dot notation to access its property x and print its value. Print p1.x. Now when we run the program, we'll get the value 5. We can also delete objects using the del keyword. For example, if I delete the object here before the print del p1 and run the program again, we will get an error because the print function no longer is able to find the p1 object after it has been deleted. We can create multiple objects from the same class. For example, we can create object p2 and another object p3, and we can print each of those objects' properties independently, which have their own copy of the class property, x in this case. When we run the program, we'll get in the output 555, each representing the value for the object's properties. By the way, class definitions cannot be empty. So for example, in this case, since I don't have anything in the class, if I try to run the program, I'm going to get an error. If for some reason you have a class definition with no content yet because you're still designing the program, you can put in the pass statement to avoid getting an error. All classes have a built-in method called init, which is always executed when the class is being initiated. The init method is used to assign values to object properties or to perform operations that are necessary when the object is being created. The init method can have as many parameters needed. For example, to create a person class, we can use the init method to assign values for name and age. Class person def underscore underscore, so 2 underscores, and then init init, and then followed by 2 underscores, followed by parentheses, which hold the parameters just like any other function. And we can start with a parameter called self, which we'll discuss more in depth later, followed by the name and age parameters. Then we can assign values for the name and age. Self.name equals to name, self.age equals to age. In this case, the self parameter is a reference to the current instance of a class. Now we'll instantiate an object of the person class. So for example, p1 equals person, and we can pass in the arguments for name and age, for example, ml, and suppose the age is 18. Then we can print the properties of this person. So we can say print p1.name, print p1.age. Now when we run the program, we'll get ml and 18. So in other words, the init method is automatically called every time the class is being used to create a new object. Without the init method, we would have to set properties manually for each object. For example, p1 equals to person, p1.name equals to ml, p1.age equals to 18, print p1.name, print p1.age. With init, we can make it easier to create objects with initial values. We can also set default values for parameters in the init method. For example, we can set age to 18. So if we don't have 18 here passed in as an argument and we run the program, then by default, it will set the age to 18. Now let's discuss the self parameter in more details. The self parameter is a reference to the current instance of the class. It is used to access properties and methods that belong to the class. Without self, Python would not know which object's properties you want to access. The self parameter must be the first parameter of any method. For example, the init method, or if we have another method like def greet. In this case, the greet method simply greets the user what their name is and what their age is. When we pass self to it as the first parameter in the function's argument, or in this case the method's argument, then the method accesses and modifies the object's properties using self. So now we just have to invoke the greet method through each of the objects. So for example, p1.greet, and we don't need this print anymore. And now we get, hello, my name is Emil and I'm 18 years old. We can have another object, p2 equals person, Tobias, suppose 25 years old, and we can invoke greet again for p2 object, p2.greet. And now when we run the program, we'll get, hello, my name is Emil and I'm 18 years old for object 1, p1. And we'll get, hello, my name is Tobias, I am 25 years old for object p2. This way, Python knows which object's properties it wants to access. We can also call other methods within the class using self. For example, I can introduce another method here, def welcome, and change this here to return. And maybe we can remove the greeting so that it's just gonna be a profile identification of the name and maybe separated by a pipe to display the age as well. And now in the welcome parameter, pass in self as the first parameter, and then we can introduce a variable message and set it to self.greet. Now we can print message plus, so we're concatenating strings here. We can also do this using f strings, but concatenation works as well. And we can say something like, welcome to our website. Now we'll change the invocation here from greet to welcome method for both objects. And now when we run the program, we get the profile of each object, in this case, Emil, 18 years old, followed by welcome to our website. Tobias, 25 years old, welcome to our website. So what we demonstrated here is we can call one method, in this case the greet method, in another method, the welcome method, using the self parameter. Let's discuss more about properties. We can modify the value of properties on objects. For example, we can change the age property on this object p1. p1.age equals to 26, print p1.age. Now when we run the program, we'll get Emil and the original age, which is the default 18, printed here. Then we modify the age to 26, and then we print the age property again, and we get 26 now, after it was modified from 18 to 26. We can also delete properties from objects using the del keyword. So here I can say del p1.age. Now the first time we printed out 18, but then if we try to print it out again, well, it was deleted, so it's no longer recognizable. Person object has no attribute age. Attribute is basically property. Properties defined inside the init method belong to each object, and we call this instance properties. However, we can define properties outside methods which would belong to the class itself, and we call those class properties. For example, last name equals Ambrose. The class property last name in this case is shared by all objects. So for example, if I print p1.lastname and p2.lastname, when we run the program, we're going to get ml18 from the init method. So that's p1's own properties, ml and 18, which differ from p2's properties, which is Tobias and 25 years old. However, the class property last name is shared among both objects p1 and p2. So both Emil and Tobias have last name Ambrose in this case. When modifying a class property, it affects all objects. For example, if I modify the last name property, person.lastname, and set it to a new last name, let's say Smith, now when we run the program, we'll get for both objects p1 and p2, instead of Ambrose, Smith. So this change is shared amongst all objects. We can add new properties to existing objects. For example, after defining object p1, I can create a new property, for instance p1.city, and set it to Detroit. Then we can print p1.city, and now when we run the program, we'll get Emil, 18, and Detroit. So adding properties this way only adds them to that specific object, in this case p1, not all objects of the class. Let's talk more about methods. Methods can modify the properties of an object. For example, a method like celebrate birthday that modifies the property age of the object by incrementing 1 to it. So when we call celebrate birthday and run the program, we get happy birthday Emil, you are now 19. So even though by default Emil gets 18 as his age, well, the celebrate birthday method adds 1 to the age, so 18 plus 1, and therefore it makes the age now 19. So if we call celebrate birthday again, now the age will increment to 20 and so forth. By the way, just like properties, we can delete methods from a class using the del keyword. For example, we can delete the celebrate birthday method like this, del person.celebrate birthday, no parentheses. And when we run the program, we'll first get happy birthday Emil, you are now 19 from this statement right here before the deletion. And then we delete it. And then when it tries to increment again to 20, well, it's deleted now. So this no longer exists. And we get person object has no attribute celebrate birthday. We can create multiple methods in a class. For example, this class represents a playlist, and here we have multiple methods, one for adding songs, one for removing songs, and one for showing songs. So first we ask the user to enter a playlist name, and then we create a playlist object using the user input for the playlist name. And following that, we have a loop that presents the user with multiple options to add a song, remove a song, and show the playlist or quit. So let's run the program, enter the playlist name. For example, we can call it favorites. Then we can start with adding a song. So we're going to pick option 1 to add a song. So we can add a song called Bohemian Rhapsody. We can add another song. Maybe we can call it Stand Up, Be Strong. We can show the playlist of the songs that we have saved so far. So we can choose option 3. And here we can see that the playlist favorites has Bohemian Rhapsody and Stand Up, Be Strong songs saved. We can choose to remove a song. So for instance, that's option 2. And we can remove maybe Stand Up, Be Strong. So this removed Stand Up, Be Strong song. And finally, we can quit. So that's option 4. We quit the program and goodbye.